So at the start of your job, your fans will be much more effective with the filters clear. The enclosure will have less leaks because the tape's just been freshly applied, things like that. So obviously, just the standard setup, if you leave it with the standard setup, the pressure within the enclosure will vary over the course of a job. So to compensate for this, certainly in the French regulations, the ED 6307, they recommend you use manual eEAR valves, manual entries, so you can adjust the amount of airflow within the enclosure coming into the enclosure. What we've done is we've added an electric motor to one of the eEAR valves, and we can use the pressure monitor to control the pressure within the enclosure electronically using the eEAR valves. So I'll just take a look at how that works now. As with everything else, the electronic eEAR valve has the backdraft shutters. One thing it does have though, when the pressure goes over goes below -5 pascals, the anti-backflow valve is actually powered by a solenoid to increase the effectiveness of the unit. So only when the pressure is below, measured by this pipe by the way, is below -5 pascals will the electro valve operate. Now it's not able to open the valve itself. It really requires some negative pressure within the enclosure to do it, so there's no danger of it accidentally just opening on its own. It doesn't produce enough force for that. But what it will do is it will slightly assist the vacuum within the enclosure to just fully open those backdraft shutters. So when you're fitting it, make sure you don't put anything over the end, over the solenoid here, so that it doesn't get, there's plenty, this part needs to move, so you can't put any tape over there. Similarly, there's a pipe here. What that pipe does, firstly, it does measure the point at which the electronic valve can operate, the solenoid can operate. The secondary thing that does, with the pipe there and the pipe on the front, we measure the pressure difference over the valve, and from our calibration we can calculate the airflow through the valve based on the pressure on either end. Like with the rest of the system, all you need to do is to power it up, and then it should automatically connect to the pressure monitor as long as you've just left your pressure monitor network. There is our valve, our eEAR valve. At the moment, if you click on settings, we can see that it's in manual mode because we haven't selected which pressure sensor we want to control it. But we'll just take a look at that briefly. If you click on the angle, you can change the position. It's actually in speed, not really an angle. You can put the angle in, but that's a percentage as well. So somewhere in the middle is 33. So we click on submit. It'll slowly change our angle to, let's close that. So it's at like 37 degrees now. That's a mid position. Then if we put it onto 0, we could close off 0. We can just like manually close the valve off. Oh, sorry, that at 0 actually opens it. It's position 63 that actually closes it. So anyway, you can manually control the valve. So obviously what we're really interested in is controlling the pressure in the enclosure automatically. For that, you have to tell it which pressure sensor you want to control. It's not necessarily the one that it's connected to directly. So you might have a wireless pressure sensor, and that might be connected to a shower, not part of the main enclosure, part of the shower, and you want to maintain -10 in there. So you could actually put the valve on the main enclosure where it's deriving the negative pressure from anyway, and that can keep the pressure within the shower from your wireless sensor at the -10 that you wanted in there. But actually what we're going to do on this occasion, we're going to choose the internal pressure sensor. We've got both the wireless and internal to choose from because we've got two pressure sensors set up on this system, but we're going to just stick to the internal one, which is there just right by the fan. Okay, so we'll submit that. Now to set the pressure, we tell it what pressure we want through the actual pressure sensor. Just like we mentioned this earlier, but we glossed over it. So I've set the target pressure for the pressure sensor to be -12. So that's the crucial bit. This here where we say target pressure, that's -12. So the valve will work to keep the pressure within the enclosure measured by that sensor at -12. The third box down shows the pressure at about 12 pascals at the start as we set it. The fan is running at 2000 meters cubed an hour. I'm going to turn the fan down so it goes down to around 1700 meters cubed an hour, and you'll see in the box at the bottom the angle of the valve will change to compensate for the reduced flow through the MPU, and it'll do that in order to keep the third box, which is the pressure box, at 12 pascals, which we see goes back to 12 pascals. If we look at the printout, we can see that at some point it wasn't able to control the pressure, so it printed out eEAR valve fully closed. It might also say eEAR valve fully open if it can't control the pressure in the other direction. There you go, eEAR valve fully open. The 300mm eEAR valve has limited scope for controlling the pressure within the enclosure. It's fine for small enclosures. On larger enclosures, you might either need several 300mm eEAR valves or a larger 400mm eEAR valve. Additionally, we have a temperature and humidity sensor, and we also have a PM10 and PM2.5 particle counter, which is ideal to see the amount of work being done in the enclosure, so you can monitor when the stripping's being done remotely and when it's, when there's a break in stripping. It shows the temperature in our office is 20.3 degrees with 41.6% humidity. The particle counter is just by our soldering station at the moment, so that's picking up a lot of smoke from the soldering irons, and that's showing quite poor air quality. There's a pattern on the display corresponding to exactly what particles it's measuring, so there's quite a lot there. There's big and small, that's what that shows. Each pressure monitor comes with these stickers, which has got a unique 10-digit code on it, and that is the unique pin number for each pressure monitor. You'll need that to enroll yourself on the system. I've visited the iot-portal.com/enroll, and it takes me to this page. It asks you your name, your email address and your 10-digit pin, and this enrolls you onto the portal, and that takes us through to our particular unit that's running at the moment. The only thing I've switched off is the flow meter for the MPU, but everything else is there. You can see we've got the internal pressure sensor, wireless one. This is the temperature sensor, that's the valve, the eEAR valve, and obviously the particle counter. You can see that keeps going in and out of just being over the limit with the amount of particles in this office because we're doing some soldering in here. The other thing to look at, on here we can control the siren. Just switch the siren on and off. It's going to be very loud. There you go. It goes off itself after 10 seconds. One of the most useful things we can do remotely is look at the logs, the graphs. They're much better looked at remotely than they are live. What the hell am I saying? One thing you're probably going to want to look at on the remote view is the logs. So we click on the little chart icon on any of the cards. I've just clicked on the internal pressure sensor. So for most of the day it's been switched off. You can see it's just zero pressure, but there's the little bit of activity we did earlier. We can zoom in on that. So it was from about between 1 and half 1. So we'll select 1 to 2. And just click on draw. Okay, and there's the pressure that we had in the enclosure during that period of time. We can also add to that the other pressure sensor. We can look at the airflow, the calculated airflow, and any of these other sensors that we had connected. We haven't actually named those units, so they come up with the MAC address at the moment, which isn't very useful. We'll go back and name them in a second, but first we'll look at the output from the other sensors. As we looked at on the actual unit, you can name the actual sensor. You can do it remotely, you can do it on the unit. They do synchronize between the two. So this is the temperature sensor, so I'm just going to type temperature. It's temperature and humidity, but just temperature will do for now. So when we click on save here, it updates the remote view, but it will also update the actual pressure monitor view as it sends it over the mobile phone network to the unit. Up here we have the users page. We click on users. There's me. I've just set myself up on that. On here we can select what notifications we receive when the unit is in fault. For example, if the pressure in the enclosure is too low, if the valve can't set the pressure because it's completely out of range, if the flow through the MPU is too low because the filter's blocked. This is where you'll get the notifications. So I'm going to just set myself up and show you an example of this. For each type of sensor you can set up the limits, so you will get the notification when the pressure goes below -20, so that's at risk of collapsing the enclosure, it's that low. If the pressure is too high, so above -10, we'll get a notification. You can adjust the limits for everything. The wireless sensor, we can put different limits in. Same with the temperature. Obviously on the temperature sensor we've set it to that if it goes below 10 degrees, that's pretty cold. We'll be notified about it. It'll print out. The alert, the siren will sound. We'll get the phone call or the text message or the email. Same with the valve. The valve is actually automatic. When it gets the extreme edges, if it can't control the pressure because it's closed or fully open, then you'll get notification from that too. As you can probably hear, I've got the fan running now, so everything's all nice and hunky-dory. We've got everything. There's no red cards at the moment, so everything's within range as we've set it. So I'm going to go and turn the fan down now, the MPU. I'm going to lower the speed the motor's running at, so it goes under pressure in the enclosure, and we'll see what happens. So straight away we can see that the internal pressure is too low and the valve has reached its extreme limit. As we've got a phone number in there now, it will get in touch with us to tell us this. So there we got the first text message. Click on it to open it. And it says there is insufficient negative pressure. We can also answer the call. Answer the call. It actually speaks to us.
Your valve is fully closed and cannot control the enclosure pressure any further. It is recommended to increase the number of NPUs or decrease the number of EACM vents.
Okay, so it gives a little recommendation as what to do, as well as tells us what the fault is.